How do we know this is going to be a t-test? I just start that or stop it? I started it good. In 2:43 on Monday, I actually had it started, then went and stopped it and talked for 45 minutes and did all kinds of stuff, and I was lost. I'm second guessing myself now. So how do we know this is going to be a t-test and not a prop z-test? What kind of clues in the data do you think? I know I haven't told you what we're testing yet, but the data itself can give you a clue as to this has to be a t-test and not a z-test. Because we measured, Drew, we took a ruler out and measured your distance. I'm not going to count what percentage of you hit 3 inches exactly, because I can't do that. I mean, I told you to draw a dot, right? A dot has area, has linear measure across. So we're going to actually see, within the realm of our measurement error, how close we got to 3. So as far as steps go, let's go step 1. Our hypotheses. What do you think our hypotheses are going to be? If I want to see how you guys are doing. We think our hypothesis. Now, here's one of these weird things. Well, let me ask you guys first your opinion. What should our hypotheses be, do you think? Let's define the variable too. Average. We're testing an average. What are we interested in? On average, what?
3.
On average, how close you guys get to 3 inches, right? So this is going to be the average distance, or the average length, whatever. The average length you guys call 3 inches. The average distance that you guys call 3 inches, on average. Now, of course, this is an average. This isn't each and individual one of you. If I had you do it 3 or 4 different times, you get a different statistic. But I want to see, as a class, are we trapping 3 inches? So what do you think our hypothesis should be? What do you think? Your call. And remember, I haven't collected the data yet. So, in other words, there's no way of knowing. Well, no, stop talking right there. What do you think our hypothesis should be? What do you think, Jack?
Not equal.
I would totally go with that, yeah? Since I didn't ask you what you guys did, let's just see if you guys are 2 off of 3 inches versus being spot on 3 inches. Does that make sense? I haven't cued you for your data. We're going to take a look at it in a second. We're going to graph it, we're going to look at it and see what it looks like and see what comes up. Maybe it's centered on 3, maybe it's not, but this is one of those, and it's one of those burdens of proof tests, Will, that you brought up last time, I think. The idea of making it 2-tailed, because I don't know what it's going to be. Up, down, we can tell on average when we get the data, and we crunch the test statistic. But for the starters, let's just see what's different. We can always refine our test later if we need to. Please, Dana. Yes, ma'am. So depending on, you will see 2 tails shaded, but depending on how far out we are, you might not actually visually see anything on the TI. Because it might be, if you guys are really off, like really off 3, the test statistic is going to be so far out in the tails that it might not be visible, but it is definitely 2-tailed. Did everybody catch that question? It was a very, very good one. All right, well, let's collect some data. Let's collect some data. I wonder what the best way to do this is. I always forget this particular one. Hey, we'll do a frequency distribution. Rosie, what'd you get?
3 1/4.
3 1/4, so 3.25. Anybody get 3.25? We got 2 of those. We got 2 of those. Okay, I'm going to do it in a frequency distribution. This might be a slight bit easier than asking every one of you. So if I come around the room and I've already gotten you, just tell me to go to the next person. Justine, what do you got? 2 and 13/16. Remember, your TI can do arithmetic. 2 plus 13/16. Because hell if I know what 13/16 is, I don't. It's apparently 0.8125. We got any of those? We got 1, 2, 2. Dina, what you got?
1.5.
1.5, 1.5. How many 1.5s we got? Chris, that was you, right? So we got 2 of those. Beautiful. Thank you, friends. Thank you, thank you, thank you. What do we got? Darn.
2.5.
2.5. 2.5s. Any 2.5s in the room? 1, 2, 3, 4, 5, 6. This is probably the best way to do it with this distribution. Yeah.
3 and 7/16.
Thank you, Michael. 3 plus 7/16. 3 and 7/16. Just the 1. Alrighty. Laura, what you got?
3.
3 even. Boom. 3 even. We got 2 3s. Yes. And this goes back to people reading a statistical result in a magazine that says on average coffee raises your blood pressure, blah blah blah. Didn't raise mine. This happens all the time. And pay attention to how many times that happens to you in your. I'm not saying you did that, Laura, because you didn't do that. But pay attention to how many times Somebody will say, I don't believe that study because I knew someone who blah. Right? You see what I'm saying? It's called death by anecdote. I can give you 3 examples right now of that study not being true. You haven't disproven that study. You've given me 3 values that fell outside of the average of that study, maybe far enough outside of 2 standard deviations, but you sure as hell haven't disproven the study. Pay attention to that in your daily lives, right? Pay attention. What we got, Harrison?
I got 2.5.
I already got you. Will, what do you got?
3.5.
3.5. Who's got it? 3.5. 3.5. There's 2 of us. All right. What do you got, Jack?
2 3/4.
2 2.75. Anybody got 2.75? There's 2 of those. Good. Kaylee?
You got
I got you already.
4 1/8.
Jessica, 4 1/8. 4 1/8 is 0.125. Actually, know that one. Oops. 4 1/8. Anybody got 4 1/8? Just the one? Excellent. Drew?
3.56.
3.56. Beautiful. Who's got that? No, just one. Okay, beautiful. Who's next?
I got 2.
2. Even. Who's got 2? Excellent. Chloe, I got you right. Ash, what do you got back there?
I had 3.
Oh, you had 3. I got you already. Who haven't I gotten yet? As far as count? Eric, please.
2 and 7/16.
2 plus 7/16. How many of those we got? We got. Do we have 2 and 7/16 already? Well, it's okay if we did. Let's have another one added in. That's okay. The TI can figure that. Josh, what do you got?
I got 3 and 1/16.
3 and 1/16. Beautiful. Anybody else got 3 and 1/16? Anybody not accounted for in the list yet? Make sure I got all our data squared away. And it doesn't matter that they're not in order. The TI can sort all this crap out and add it all together, so that's totally fine. Cool? All right. Let's take a look at it first and see if it tells us anything. Let's take a look at the data, see if it tells us anything. Let's get a couple graphs going. Let's get a histogram, let's get a box plot, let's get a modified box plot. Why not? See if there's any outliers. So let's turn the first plot on. I'm going to turn on a histogram. Yep. L1 and L2 sound pretty good. Second plot, we'll turn the modified box plot on. We're just ready to go. Yeah, ready to go from last time, I guess. Yeah, I think we're golden. Zoom 9. There's our data. I'm going to move it around a little bit and get some more logical. Whoops, what's the graph? Oh, that's right. I had some crap in 105. Okay, there it is. I'm going to mess with the window a smidge just to kind of clean it up a little bit. 1.5. We didn't have any 1.5 guesses, did we? Or did we? Maybe we did. Let's just go. We had a couple of them. Okay, we'll just go like 1 to 5 by half-inch increments. Maybe that's. See if that shows us anything. Okay, that's not bad. And we'll go raise the Y max to 15 to make some room for the plots. Okay, there's our guesses. Now, how did we do? Well, it's hard. This is where the TI sucks. Because the TI doesn't show you a scale. So there's definitely a mode in our data, but we have no idea where the mode is until I look at my window. Xbin was 1. Here's 1. Here's 1.5. Here's 2. Here's 2.5. Here's 3. Here's 3.5. Here's 4. Here's 4.5, and so forth and so on. So how did we do? I'm saying we didn't do too badly because we're a little bit underestimated, it looks like, yeah? We're a smidge underestimated because 3's here. 3 is that line. So if you trace that line up, it goes through the box of the box plot, which, yay, our middle 50% caught it. But we've got more than half of us underestimating it. But again, that might not be significant because the balance point might be 3-ish enough. That's the whole point. It might be 3-ish enough, yeah? 3-ish enough. Make sense? Okay, let's test it. So we're going to set up a curve. Basically, this is our data, but we're going to set up a sampling distribution. I'm going to turn this off for a second. What we need to know is, based off of this sampling distribution, which is centered at 0, although we know that that's 3 inches. We're calling it 0 because we're going to normalize it down. We have to know where our average was, and our average, let me run it real quick, I should have calculated that. Our average was 2.8 inches. Our average was 2.8 inches. So as we said, it's a little bit underestimated. The question is it so far underestimated that it's outside and into our little 5%, excuse me, that won't even be 5%, that'll be 2.5%, won't it? Because we're running a two-tailed test. This bad boy will actually be 2.5%, and we'll also have that over here. This goes back to Danny's question about the 2 tails. Now, do you guys remember Do you guys remember what Will said about burden of proof last time? It was really astute, and actually like 5 weeks early, so thank you for that, sir. So what he said about burden of proof with a two-tailed test. Two-tailed tests are harder to get this believed on than one-tailed tests. And now you can see why. See, we set the test up before we collected the data. Good Lord, good, excellent. We set the test up before we collected the data, so we had no idea where our data was going to be, whether it's an under or an overestimate. Then we collected the data. And then once we collected it, we looked at it and said, oh, we fell to the left. We fell to the left side, which means we underestimated on average. But I'm not going to change my hypothesis now. I'm going to leave it as a change. I'm going to leave it as a change. But do you see why this is harder to, if you will, win for the research than a one-tailed test would be? Can you see why? This is only 2.5% versus would it be for a one-tailed test? It would be what? 5%, which means this would be further which direction? You got to kill it. It'd be further this way, which means our data would have to travel further, be less unusual to trigger us to believe that. Here, the burden of proof is higher because we have to get further left into that region to go, something's up. That's indicative of a two-tailed test. Does that kind of make sense? Hopefully it makes sense. Good, let's find out. Let's find out. We need a test statistic, we need a p-value. That's steps 2 and 3. What's our test statistics variable? Do you remember? You got it, Linz. T, big P for a p-value. Let's find out what they are. All right. Stat, test, t-test. There's our buddy. Set everything up. Data is what we want. Our mu naught is just 3. We're going with 3 inches. List L1, frequency L3, or excuse me, L2, right? L2. And let's go with the two-tail. All right, with the two-tail. Let's draw it. Let's see how we did. Here she got. Oh crap! Hang on. Sorry. I got plots turned on. They get in the way sometimes. Let's turn those off. Run it again. I always forget about that. Here we go. I see a whole lot of area, and I'm going to see that area mirrored over here. Two tails. Two tails. How we doing? How we doing? How we doing? This is the key. I just found a great study I want to include on your guys' next, either in class or out of class. I haven't decided which, where I give you those results, and I have you come to the conclusions based on context, rather than actually have you run the tests themselves. What do you think? What do you think? You can say this, you can actually verbalize this 2 different ways. You can say it with a double negative, or you can say it without using any negatives whatsoever. There's a couple different ways that you can sum this up. So let's practice. Let's practice verbalizing the conclusion. What do you think? What's the conclusion for this? You feel brave. Feel brave. Feel brave. You know this. You know this. Let me ask you a related question. Which hypothesis do we believe with those results? Let me ask that question first. Which hypothesis do we believe with those results? We believe the null, because there's no reason not to. How do we know? How do we know when we believe the alternative? When do we believe this guy?
When our p-value is not within our tail.
Exactly. So what number are we looking for usually?
5%, but no, I guess like the, yeah.
Oh, careful, it's always 5%. Eric, thank you, it's always 5%. You see how I split the 2.5, 2.5? It's always going to be 5. It's always going to be 5. So as long as it gets down below 5, then we say, okay, now I believe the alternative. That's nowhere near below 5. It's way above 5. It's within the confidence interval. The confidence interval of what? What's that confidence interval built around?
99%.
Good, 99%. Built around what believed value were we testing against? What were we trying to see? Laura, go ahead.
Oh, 3.
Yes, we were trying to see if you guys could approximate 3 inches on average. Does it look like you can? Yes, it looks like you can, because there's no reason to think you can't. You see, that's how I said there's 2 ways you can say this. It looks like you guys are puberty. It looks like you guys are approximating 3 inches just fine, because there's no evidence to support that you're not approximating 3. See how I'm saying that? One way, I'm saying it kind of in agreement with this. There's no reason to think that the average length you guys call 3 inches isn't 3 inches. Another way of saying it is, I can't believe that the average length you guys are calling 3 inches isn't 3 inches. Double negative cancels out. All the negatives go away. You guys are hitting 3 inches on average. Does that make sense? Harrison, answer that question.
Does
That
it make
question.
sense?
Yeah, about your eyes kind of
It
furrow.
sounds, it makes sense when you say it.
Oh! It's gonna make sense when you say it too. It's only because you're getting used to saying it. That's all, brother. That's all. You're used to saying it. That's all. So, let's back up. Let's do it step by step. Are we okay setting these up? Decent? Ish. Get in there. Oh, I got 3 more for us to do today. Don't worry. Don't worry. Once we have this and data, can we get these pretty quickly? We know what we're doing. There's only 2 tests we're in right now, the prop Z and the teeth. So go. Taking the results from that, can you decide which one of these you believe? Okay, so let's make this automated. Let's make this automated. Slide over here. Stop this again. Or stop and start.